Good day everyone. In this tutorial, I will show you how to use sentence transformer library in order to get sentence embeddings and then calculate sentence similarity scores. This method is used in many applications, for example in chatbots, where you need to find similar questions to the question of a user, and you can use sentence similarities in order to check the similarity of the question and the answers. You need to pip install sentence transformers library, and after that you import sentence transformer function. By using this function you can download necessary models which are pre-trained and ready to use. Here this is the name of the model. Now I will show you how to find it. To find the model you need to go to Hugging Face website, and here you can search for sentence transformers, and as you can see we have many choices. For example, let's take the first one, and here you can check the details of the model. Also, in order to use it, you just copy it here with the button, and then you paste it here as I have already done, and then you will get the model from the Hugging Face website. After you import the library and the model, you can start using it. So let's move to this code. In order to show the results, I have used 6 different sentences, and if you pay attention, the pairs are close in meanings. For example, in the first pair we have the computer science students passed all the exams successfully, and the second sentence is university creates a good environment for learning. So these two sentences are close in meanings or in the context. And let's see the next two sentences. My dog enjoys evening walking in the local park, and dogs are very friendly animals. Again, context-wise similar sentences. And the last pair, industry plays big role in the economics of a country. The experts expect economical crisis in the next year. So by using such examples, we will see that if the similarity scores really work or not. We expect that the pairs will be close in scores, so we will have higher scores for the pairs, but we will have lower scores for other sentences. So we have all our sentences in the sentences variable, and then by using model.encode function, you can create the embeddings for the strings, and then we can see the shape of the embedding. As you can see, it's 6 by 384. 6 is the number of strings you have used in the list, and 384 comes from the model. This model has been trained to have 384 numbers as an embedding. Now I will print out one of them to check. As you can see, we have an array of numbers, different numbers, positive and negative, and the number of numbers here 384. If you check Hugging Face for the model, you can see that it has been written that it maps the strings to 384 dimensional dense vector space. In other words, every sentence, every string is transformed or represented by a 384 dimensional array. So as we get our embeddings, we have completed the first part. So now we have the sentence embeddings with us. We have completed the first part successfully, and now we can calculate cosine similarity scores with these embeddings and check the scores for each sentence. In order to calculate cosine similarities, I have used the function of PyTorch library. You can import it from the sentence transformers library and use it as this example. Here I take each embedding with the for loop and then use the embeddings variable and the embedding variable. In this way you will calculate the score between each sentence and the 6 different sentences. Let's run and see the scores. Here let's take it one by one and check the first one. The first one is the score between the sentence and itself. As you expected, it's 1. And let's see the other ones. The second score is 0.3, and the others are quite lower than that. We have 2 negative values and 2 lower values. So If you remember the sentences, the first two ones are close in context. So we have the highest value for the second sentence. So as it's the same two sentences, we will have same score again with 0.3. And now see the next example. The third sentence is close in context with the fourth one. So we have the highest score here as the fourth point with 0.49. And the others are quite lower than it. In the last example, we have the highest score at the last point. So, because it was the closest meaning with the last sentence. So we calculated similarity scores from the embeddings. In this way, you can calculate similarity scores for your strings. As I said, you can use it in chatbots or other NLP programs. I also have a Medium article about this topic. You can also check it and read it if you like. The links will be in the description for both code and the blog. At the end, don't forget to check the GitHub code and the Medium article. Thank you so much. See you in the next videos.